We move on to 190. 198. That's what I should see for the first two questions. I am telling you now, I called that practice. You'll be doing an assignment very similar to this today or tomorrow. So if you're going to skip your practice stuff, these two had better be perfect. Any questions there? There shouldn't be, of course, because everybody should have done their practice with the answers and would know if they were doing it right. Oops. And then, as I said yesterday, this bottom thing was a misprint, and it shouldn't even be there. Any questions? Lovely. I remind you all, this is an incredibly important unit to the rest of this year's math and all of your next 2 years' math. So it is really bad practice to skip. Move to page 199, please. Draw two lines that are parallel. What does parallel mean? They're never going to touch, right? So everybody put their first line at your x-intercept of -4, 0. And your y-intercept will be 0, 3. Everybody draw that line, please. I'm going to wait a moment to make sure everybody can do it. Then when I draw it, I'm going to see how many people have to erase and redraw. That is long enough. And that should be your line. I will zoom in to make it easier to see what it is we are indeed doing. Yeah? Now, we're going to draw another line, but this time our x-intercept is going to be 4, 0, and our y-intercept, our next point is going to be 8, 3. Now, all of you should recognize that that second line is the exact same line as here, just slid over to here, yes? Everybody understands that? So since it is the exact same line, I know that it will be parallel, right? Because these lines will continue on for how long in this fashion? Forever. So this will go up 3 over 4. This will go down 3 over 4. This will go up 3 over 4. Down 3, left 4. Yes? And those lines will never touch. Agreed? Why will they never touch? Because they're going in the same direction at the same slope, right? That is what makes parallel lines. That slope is 3/4. This slope is 3/4. So what does that tell us? If they're parallel lines have the same slope. Now, that's easy to see, easy to understand, easy to illustrate, right? What causes me problems is you guys don't recognize that has a flip side. And the flip side of this statement is if two lines have the same slope, then they're parallel. If you already have the lines, easy peasy. They've got the same slope. You can see it. But a great many of you forget that if two lines have the same slope, they're not on the graph, then you're like, oh, I don't know anything about those. But you do, because if they have the same slope, they must be parallel. Okay? All right. Now, the next one is going to take a little bit more explaining because it needs two parts. First thing, I got to talk about, what does the word perpendicular mean? Anyone? Not necessarily up and down. Nobody? Okay, what did you mean by up and down? Who said up and down? What did you mean by that? Straight line up and down. Okay. Well, you need two things to have perpendicularity. And those two things are any two, doesn't have to be lines, but any two things that intersect at a 90-degree angle. Okay? Everybody cool? So, we're going to do two things on this graph over here to prove it. On the left, we're going to do the easiest kind of perpendicularity, vertical and horizontal. Okay? What is that point right there? You can count it up there. -8, 4. Everyone agree? Now put another dot at -8, -4. Now we all know that the slope of that line is undefined, yes? Why is it undefined? Yeah, but what makes a straight line an undefined slope, Lennon? Yeah. What makes it undefined, though? What is it about it that makes it undefined? Mathematically speaking, what is slope? A slant, but how do I find slope? Rise over run. Thank you. What is the rise here? 8. Everyone agree? So this guy is 8/0. Yeah? Everybody cool? Okay, now, I'm going to use a different color. You don't have to. I'm going to put a dot right there. That is -9. Oops, not underlined, dummy. -9, -2, correct? Now let's put a dot at right there, which is -1, -2. Horizontal, vertical. Do they meet at 90 degrees? So they are perpendicular, yes? What is the pink guy's slope? 0 over what? 8. What do you see? Not opposite. Reciprocal. Everybody cool? Everyone agree? Okay. Now, I'm going to use a fourth color. I'm going to put a dot at 0, 0. Okay? And we're going to put a dot at 4, 4. No, that'll be too small. Let's put it at 7, 7. Everyone cool? So what is that guy's slope? How far did I rise and run? It's 7/7. Yeah? Everyone good? All right, now we're going to put our next dot at 0, 7. Other way around, 7, 0. Sorry, 7, 0. And I want to make it green so it's easier to see. 7, 0. And our other dot at 0, 7. Everyone cool? Now we're going to connect them. Now, what is that guy's slope? What's his rise? 7. What's his run? No. Rise. -7. Is everybody cool? Now, This guy obviously makes a square, yes? So what do we know about the angle where it's the diagonals are going to meet? What must they be? They must be the same. And what are they? They're right angles, right? So these guys are also perpendicular, just like this guy, yes? When this guy was perpendicular, what happened to the slopes? Somebody already said what that is. It's a reciprocal. When this guy was perpendicular, what happened to the slopes? You said it already when you meant it, when you said what you said for perpendicular. They're opposite, aren't they? Everybody with me? So perpendicular lines have two characteristics. What are they? Their slopes do what? Reciprocate and are opposite. So perpendicular lines meet. What does that tell us about their slopes? And remember what opposite means. Positive or negative. And they reciprocate. And remember what that means. If one slope is A over B, the perpendicular slope, that's what this symbol means, is negative B over A. Rise over run, rise over run. Does everybody understand? It's the exact same numbers. They just flip and you switch the sign. Is everybody good? And we just proved it in two different ways, right? So, what does it tell us? Parallel lines have the same slopes. Perpendicular lines have opposite reciprocal slopes. So, fill in that. I want to know all 7 slopes there. And this, of course, is just the concept. It has nothing to do with the math we're going to use yet. All right, what's the first one? Kind of. Negative 3 over 2. What's the second one? 1/7. Positive. What's the third one? 4, because it's not perpendicular. It's parallel. What's 5? No, it's already negative. It's got to be opposite. 11 over 5. 0. One over 0, which is undefined. And if I am undefined, what's my opposite slope? Good gravy, guys. You just did it. Zero. Decide if ST is parallel, perpendicular, or neither to AB. What determines parallelism, perpendicularity, or neither? What is the concept that determines that? Slope. So I have to see if the M of ST is equal to the M of AB. That would make them parallel. If the M of ST is opposite and reciprocal of the M of AB, that would make them perpendicular. If they are not equal, then that would make them neither. So, how do I check that? How do I check the M of ST? Pardon me? What do I do? You all did your practice from 196, so you all know how to find a slope with 2 points. And you just did a practice assignment on it. So, I should hear 30 people clamoring to give me the answer. You could graph it, that would take forever, or you could do the thing that is better than graphing that we proved yesterday, which is algebra. How do I use these values to find these values? Excellent. I have for the ST, which I will do in blue, y2 minus y1 over x2 minus x1. And then I'm going to check that against what? Same thing, but in pink. Go ahead and do that. Remember, who chooses which is x1, y1, y2, x2? Who makes that choice? You do. Does it matter what you do? No, it does not matter which way you make, what you make x1 and y1. However, once you have decided on an x1, that partner is y1. Right? Go. All right, that is a goodly amount of time to have subtracted 4 numbers. Are they parallel? Are they perpendicular? Or are they neither? I'll wait 5 seconds for somebody to offer to tell me what they are. Joven, you say they are perpendicular. What is the slope of ST? 2 over 1. What is the slope of AB? Pardon me? Negative 1/2. Absolutely correct. Because this, of course, simplifies to negative 1/2, and this, of course, is actually positive 2 over 1. And you can see they are indeed negative reciprocals of each other. Is everybody good? All you are doing is once again finding slope. How important is slope? Very. If you cannot find slope in all 7 ways, then you are in trouble for the rest of this year, all of next year, and most of the 12th grade. If you learn nothing from grade 10, learn how to find slope. Okay? Next question. If this triangle is a right triangle, what must it have? It must have a 90-degree angle, which means 2 of those sides meet at a 90-degree, yes? Which means 2 of those sides must meet at opposite reciprocal slopes, correct? If I just start right now, how many slopes do I have to check? I got to check all the corners, don't I? If I just start right now, right? If I told you there was a way you only had to check 1 corner, would you be interested? Of course you would. How do you check only 1 corner? What did you want to do last time? Nice. You would want to graph it, right? So, let's graph it. Does the graph have to be perfect? No. Of course not. As long as it's a decent sketch, we'll be in business. Side A is where? Or point A is where? Left, 1, 2, 3, and up 1. Everyone agree? Where's point B? Right, 1, 2, 3, 4, 5, 6, and down 1, 2. There's B. And where's C? One, 2, 3, and up 1, 2, 3, 4. There's C. And that makes a triangle. Where is the only possibility of a 90-degree corner? C. So do I need to check all the slopes, or do I only need to check AC and BC? That's the only one I need to check, right? So, how do I find the slope of AC? Rise over run. I could count it, or, pardon? I could do y2 minus y1 over x2 minus x1. Do I care which one you do? Great, go. Tell me what the slope of AC is. Excellent. Now I got to do the same thing for BC. Can I count it on the graph? Yeah. Can I do it with algebra? Yeah. Does the teacher care which way you use? No. So go. Is this a right angle triangle? Yes, because that is 90 degrees because of negative reciprocal slopes. Easy peasy, lemon squeezy. Everybody good? Yeah? Excellent. Next, algebra practice, because you desperately need this. If this is true, then what do I know about the slope of AB and the slope of CD? They would be the same, wouldn't they? Which of those can I find right now? Slope of AB. How would I find it? Algebra. So what would it be? Is it possible to do it wrong if you label it? No. x1, y1, x2, y2. 10 minus 5 over 7 minus 3, 5 over 4. Yeah? Okay. What is the slope of CD? I'm going to label it the other way around, just to be contrary. x2, y2, x1, y1. So what would CD be? 2 minus a over 0 minus 1, which would be 2 minus a over negative 1. Now, if these are parallel, what symbol goes right there? Between the two, if they're parallel. Equals. Does this look like what we ended yesterday with? Is it fraction equals fraction? So what do we do to solve that and figure out that a? Cross multiply. Make it happen. Go. When that is done, sketch a graph. How do I find 13/4? He waited patiently. For 30 grade 10 students to tell him the value of 13/4. Josh? You could, but then I would have to have 20 steps out this way. Or I lie, 40 steps, 28 steps out this way to get to 7. I've already set my scales as 1 each, so I didn't have to make a giant graph. So what is my other option? Jacob? Of course you turned it to 3 1/4. 1, 1, 2, 3, and a little bit past. And it would go right up there. Well done, Jacob. Questions? No? Lovely. What if AB is perpendicular to CD? Do we already know AB's slope? It's negative, or it was 5/4, yes? Was it not? Yes. We already know AB was the black line, and we know it was 5/4. And we already know CD was done properly. What was CD? It was 2 minus A over negative 1, correct? But I don't want parallel anymore, I want perpendicular. So what does perpendicularity do to CD's slope? Reciprocates it and opposites it. Ugh. That's hard to say. So what would happen to this to reciprocate it? What would it become? It would be, just to reciprocate it, it would become negative 1 over 2 minus A, right? And then to opposite it, what happens to that negative? It becomes positive. So this would now be, it would have to equal the opposite reciprocal of this, which would be 1 over 2 minus A, wouldn't it? How do I solve that? Cross multiply. 4 equals 10 minus 5A. Solve that. And then, of course, graph it. Can we put it on the same one? It'll be kind of ugly. I'm just going to erase these because I've already got my scales. I know that A went from 1, 2, 3, 4, 5, 3, 5 to 7, 10. There was A. And CD went from 0, 2, which I've got right there, to what? 1 and 6/5. How do I do 6/5? 1 and just a little bit more than 1. Now, please notice, what do you see about those two lines right now? Yeah, they're what? They're not touching. Just because lines aren't touching, does that mean they're not perpendicular? No, because what will happen with this line? It will continue. Where? Down, over, and eventually they will cross. Does everybody understand? Because in math, how long do these lines go on? Forever and ever. In reality, they often stop, don't they? Because if we were graphing time, we wouldn't have negatives, yeah? Everybody understand? In math, they go on forever. So even if they don't touch in your work, they are still perpendicular. Is everybody good? All right. That is the only concept for that lesson. Now, again, I stress, none of you are going to, but I highly recommend looking at 202. I highly recommend it, as a matter of fact. Now, you notice what is coming next? quiz. After 202, what is after the quiz? An assignment. That assignment is on 204. I know every single one of you is going to go to page 204 right now. I know that. I'm not stupid. I'm going to tell you again, since it's an assignment, it's for marks. You had better know what you are doing. How will you know what you are doing? You will practice. How will you know if your practice is correct? You could check the answers. Where are there questions with answers? Page 202, the page you're all going to skip and go straight to the assignment. And then immediately start asking me questions about how to do it. Whose assignment is it? Yours. Who needs marks in Math 10? You. Who already knows how to do the assignment? Me. I don't need extra practice on this. You do. So should you do some questions from 202? Yes. Will many of you? Still, even after this lecture, probably not. I will walk around and I will see everyone working on 204. But if I say right now I won't help you on 204, you will all say, go home and say, my teacher won't help me. And then I'll get in trouble. So I'm in a bit of an interesting situation here, right? Right. But I did just record this whole thing, so I would be able to say, this is what will happen. And this is what did happen. Should I get in trouble? I know, right? Evidence. Go.